Did I cover induced magnetism? Just check. No, right? Okay. So I think what we have covered so far is introduction to magnetism. Magnetism. Right? So here, what did we learn in introduction? Like what are natural magnets and artificial magnets, right? Natural and artificial. Did we learn about it? What was artificial magnet? Naturally found magnet, which is also called lodestone, right? So it is also called as lodestone, right? Which is basically nothing but iron oxide, FeO3, I think. Right? You can look in the book. Did I cover all this or no? I really can't remember. You have to tell me.
I don't know.
Fe3O4. So this is basically iron oxide. So this is a natural magnet. Now, what is the problem with natural magnet? It doesn't have a. It has a irregular shape. Yes, it has a irregular shape. Okay, so it is not very convenient to use. Hence, not very convenient to use. Right. So that's why what we need is artificial magnet. Artificial magnets are man-made magnets, right? So, what are the examples of these magnets? The bar magnet, if you are familiar with, right? You are familiar with bar magnet. Then there is horseshoe magnet, horseshoe magnet. So how does the bar magnet look like? Just a plain iron rod, right? In the shape of a bar. Okay, so this is a bar magnet. How to make this? That also we'll learn in this chapter. And horseshoe magnet, so it is a U shape magnet, right? So N and S. What N and S indicate? Poles. Poles. These are called poles. So you can see that each magnet has got 2 poles. So it's a bipolar substance, right? Can a magnet have only 1 pole? Can it have? Suppose I break it, then it will still have 2 poles. It will still have 2 poles. Then what is the difference between the previous and the new?
It will just be half.
Yes, the magnetic strength will become half. Right? So it can be like split along the pole like this. So this is called magnetic axis. The line joining the north and south pole is called magnetic axis. Okay. So either you can have 2 long magnets or you can break it along the perpendicular passing through the magnetic axis. So either ways, right? You will get 2 magnets. In the first case, you will get 2 long magnets like this. But now each magnet will have half the strength of original magnet. Okay. Or if it is broken in the middle, you can get 2 magnets like this. Again, the same thing. This will be not. So it develops a opposite polarity, right? So it will always have two poles. Understood? Then what do you have? What are the other artificial magnets? You have magnetic needle. Needle. Okay. How is magnetic needle? So it is balanced on some pivot like this. Okay, so it is balanced on some support. Let's say this is not installed. Okay. And then you also have magnetic compass. All are magnets only, but in different installation. Like here in the magnetic compass, you have magnet only, but now it is housed in this kind of enclosure. Again, one of them will be north. So the one which is shaded is north and non-shaded is south. Clear? So this is magnetic compass. Okay, so all these are different types of magnet. Now, properties of magnet. What did I tell you? I think, did I explain properties of magnet?
Yes.
What did I write in properties of magnet? Right. First is it has directive property. Is it mentioned? We have written properties of magnetic field lines. Have we written properties of magnet? No. Okay. Likha hai na? So this is the property of a magnet. So what is directive property? Anybody knows what is directive property? It's related to direction. So what is the directive property? Whenever a magnet is suspended freely, it will point in geographic north-south direction, right? So that's directive property. Right? Second is attractive property. What is it? Property.
Unlike poles attracting them.
Yes, you can say that, but it is something else also. So the magnet rests in geographic north-south direction. When suspended freely. Okay, this is the directive property. What about attractive property? It has a tendency to attract small pieces of magnetic substances such as metal, iron, metals. So it has tendency. Have you signed the attendance? To attract magnetic substance. Such as pieces of iron. Then third is like poles. What happens to like poles? Repel. With the other hand, vibrate. Okay. What is the fourth property? Always exists as dipole. Always, magnet always exists as dipole always exists, always has two poles. This is called dipole. Okay. Okay. So these are some properties associated with magnet, which you must know. Apart from this, now we will talk about what is magnetic field lines. That I've already spoken. Is it clear? Clear? Can I erase the left side?
Yes.
Next is induced magnet. Any idea what is the meaning of induced? What is induced? Induced meant to, like, suppose there is a non-magnetic substance, but now we did something to it so that magnetic character is visible in it. Okay, so it is a temporary magnetism, right? What is induced magnetism? So suppose you have a small iron bar, it is not a magnet, right? Now if we keep it close to any permanent magnet. Oh, by the way, have you written it? Everybody's written it?
No.
So this I erased, you had written that?
Yes.
ठीक है, पहले complete कर लो फिर मैं. How many of you are not writing? You are not writing, right? No, these are some different things, I think. Achha, what about the right side? Right on, right on. I mean, these are not the same things I got in the last class. Some might be different. Yeah, sure. So how many lectures we have taken on magnet? Just one is it? एक ही लिया है ना? ठीक है, हम लोग कल इंट्रोड्यूस ही किया था लास्ट. Written? Let me know when done. Done?
Yes.
Yes.
Okay. Now see what I was saying. We have a permanent magnet, right? Pay attention, everyone here. We have a permanent magnet. So obviously it will have attractive property, right? And now we have kept a magnetic substance, an iron bar near it. Okay. So is it a magnet?
No.
No. But now it is kept near a magnet. Then what we experience is when the iron bar is kept near a magnet, now there are some iron particles, right? Let's say some iron particles are kept here. Now when this magnet is not near this iron bar, then these iron particles are not getting stuck to this iron bar. Okay. But when a magnet is brought near this, then this also becomes magnet. Then what happens? These go and get stuck here. Right? This is what happens. So that means it must have acquired magnetic behavior. But is it? So what you will experience is now if it is taken away, again it drops down. Okay? Meaning it becomes a temporary magnet under the influence of a permanent magnet, which is either near it or it is in contact with it. Is it clear? Then this acquired temporary magnetism by this iron bar is called induced magnetism in this. Got it? So it is acting as a magnet under some situation, not always. That is why it is called induced magnetism. Understood? Okay. So it is the temporary magnetism acquired by an iron bar or any magnetic substance when kept near or in contact with a permanent magnet. Is this understood? Write it. What is induced magnetism? It is the temporary magnetism acquired by an iron bar when kept near or in contact with a permanent magnet. So how does it acquire magnetism?
It turns the iron bar into a magnet.
Correct. So these are small filings or iron filings. You understand what is filing, right? So if you file an iron, the powder, so that is small iron filing. So you said it, like it acquires the magnetic behavior. Means what does it acquire? Poles. Then it will temporarily develop some pole. Now how will it develop the pole? Now I said when this is getting attracted towards this, that means which pole should be on this side? South pole. Okay? So whenever induced magnetism is acquired by the iron bar, opposite pole will be developed near the pole of the permanent magnet. Right? So suppose north was here, then south will be developed here. And at the far end, the same pole will be developed. Is it clear? So this is how the poles will be induced. Now it is induced. उसमें आ गया, है ना? पैदा हो गया या प्रकट हो गया. So that is induction, right? Now, so what must have happened here then? Like this developed poles, these every particle has also become magnet. You understand? Is it clear now how the induced magnetism is functioning? So see. So therefore, now let's say there are some nails kept here, right? Like that, a heap of nail was kept over here. So what will happen? Once it becomes a magnet, so it will, one nail will get stuck here. So what it should be then? This should be south and this should be north. Okay. Likewise, you can have so many nails, right? So north, south, like that. It will keep developing. Okay. So each of them become a magnet. That is why they are attracted. Got it? So we can say induction precedes attraction. Okay? Why is it attracting? Because the magnetic substance is made temporarily a magnet. And that is why it is attracting. Okay? So इसका मतलब क्या? मैं कितना भी किल एक छोटा सा बार मैग्नेट में it will hang. So when will it start breaking?
After a certain point, it will
When
become
the
weak.
magnetic strength start decreasing.
Yeah, in a way, right. So every magnet I said is a strength. So magnet is exerting a magnetic force, right? And these nails weight, they will have a weight, right? So force is also weight. So when the magnetic force becomes equal to the weight of all these nails, okay, it cannot hold anything more than that. Force and weight are same, right? You agree? What is the unit of force? Newton.
Newton.
And what is the unit of weight? Newton. Isn't it? Unit of weight is kg. What is kg? Unit of so unit of weight and unit of force is Newton. Okay. So when the magnetic force of the magnet becomes equal to the weight of the nail, it can only hold that many nails. Okay. So is induced magnetism clear? Huh? I think that is, well, you should be able to answer all the question on induced magnetism now. Okay, next topic is lines of magnetic field. So, in the last lecture I covered properties of magnetic field. And did I define what is magnetic field? What is magnetic field? What is magnetic field? Yes. और जल्दी सरेंडर कर दो तो लिखा है कि नहीं देखो तो लिखा है कि नहीं नोटबुक में पढ़ के बताओ
It is the reason.
It's around the magnet.
स्पेस अराउंड द मैग्नेट पढ़ के बताओ ऐसा कोई जरूरी नहीं कि याद करके बताओ So everybody read what is magnetic field. Raise your hand. Tell me.
The space around a magnet in which the magnetic compass needle lies
in a direction other than,
rotating.
okay, that's magnetic field. So magnetic field is a property of silent or disconnect. Everybody keep your phones on silent. I'll also do mine. So actually phones in other classes are not allowed. Right? It has to be submitted at the reception. So since it is allowed, keep it silent. Okay. So let's say you have a permanent magnet like this, right? So let's say you have this as south, this as north. Okay. So how do I plot the magnetic field of this magnet? So I have kept it on. Let's say this is the tabletop. I have kept a magnet over here, right? Let's say this is the magnet. I have kept it over here. Okay. So I have a chart paper and then I've kept a magnet over there. And I will draw the boundary of the magnet. Okay. And I'll put north, south, whatever. Okay. How do I know which is north pole? So when I keep a magnetic compass over here, so the north pole will, if this will be north pole, if the magnetic compass north pole is away from it. Okay. Got it? So how is magnetic compass north pole? When it is away from it, that means this is north pole. Correct? So let's say if I keep a magnetic compass over here, imagine this is the geographic east, west, and north, south. So when this magnet is not there, right, it will point in this direction. Okay? Because that's the property of any magnet. But when I bring this magnet over here, it will not point here, it will be repelled and it will go like this. Okay? Understood? So now then I understand that this must be north pole because it has repelled the north pole of magnet away from it. Is it clear how to identify which is north and which is south? Right. Now generally north will be like painted. Okay, so you know that that is the north in your laboratory. Okay, or it will be marked, whatever. Then once you have kept the magnet over here, so just keep the magnet at any point, for example. So you will figure out that it is pointing in this direction. Now mark this point also. Okay, you have these 2 points. Now lift your magnet and align the tail with this point. ठीक है? ये इसको यहाँ से we picked up and kept it over here. So align the tail and then follow the north pole and mark that point over here. Again, keep the magnet. You will find that it is going in this direction. So when you do this, right, exercise, you'll have so many points like this. So what you will see when you come over here, the compass is pointing in this direction. Okay. So on your chart paper, you'll have so many dots, right? So when you join the dots, you'll find that the magnetic field line is traveling in this direction from north to south. Got it? How to plot the magnetic field line of a magnet? This is how you will do it. Okay? This is about plotting the magnetic field. And likewise, you can start from any point, right? So you will find that it completes a loop like this. Now, how do I know it completes a loop like this? So I have a magnet, right? I can keep a glass plate and keep a chart paper over here. So with the magnet, I have actually drawn the impression that magnet is in this area. Then you will see that it completes the loop. Understood? Okay, this is how it is. So likewise, so many lines will be drawn. So what is the conclusion? We have already written all the points in the last class. I have told you that all the field lines emerge out of north pole. Why? Because the north pole was repelled, and it enters into south pole. Okay. So this is how it is. Is it clear? Now, how do we define magnetic field? So it is existing at every point, isn't it? It is existing at every point. Is the direction same at every point? No, because see the compass. Everywhere it is along the tangent at the curve, right? Where is it pointing? Along the tangent at that point. Clear? So all the details I am not going to explain again because I have already told you. So you can only write down what is magnetic field, or have I explained that also? Region around the magnet. Have I given you that? The one which is it?
Magnetic field around a magnet in the form of fluid curve.
So that is a visual representation of magnetic field. So that is field lines. So magnetic field is, okay, write down. There is always a confusion. So you first write down. Okay. You should know what is magnetic field and what is magnetic field line. So magnetic field is a region or space around a magnet, around the magnet, or anywhere, permanently, कोई भी. Where the magnetic compass rests in a direction other than geographic north or geographic north south. Okay. So why it happens? That's the next question. Okay. So why rests in direction other than geographic north south? What you have to tell me why a magnetic compass always rests in north south? Why? Why? The directive property I told you, the magnetic compass pointing in a north-south direction of Earth. Why it is so?
Because when a magnet is really suspended, it points to the geography.
Why?
Why?
Because it comes the magnetic field.
Yes, because Earth itself is a magnet. Okay, Earth is a giant magnet, but its magnetic field is very weak. Okay, so when there is no magnet near the magnetic compass, because Earth is a magnet, right? We will learn Earth's magnetism separately. So Earth का जो south pole है, वो north side में. Earth's magnetic south is in the geographic north direction. That is why the magnetic compass always points towards north. Because what we see north of Earth is actually magnetic south of Earth. Ulta hai. Okay? So I'll explain that in a little while, or maybe in the next class. So magnetic field line. अब ये क्या है? These magnetic field lines are of this magnet. Okay, so this is a local field line apart from Earth. Understand? These are the local field lines of this magnet. And there are Earth's magnetic field lines also available, but those are weak as compared to local field of magnet. That is why the magnetic compass is not influenced by this. ठीक है? तो जहां पे भी the magnetic compass is getting influenced by this magnet, okay, that region or that space is the magnetic field of this magnet. Earth's magnetic field is everywhere. Got it? Okay, but when we have any other magnet other than Earth, its field will be, its local field will be stronger than Earth's magnetic field. And that's why, and what is the behavior? It will always align itself in the stronger magnetic field. ठीक है ना? Earth की magnetic field को it has overridden. ठीक? Understood? Okay. Now what is magnetic field line? अच्छा, अभी field is there, but can we see? I am telling you that Earth's magnetic field is everywhere. Can you see it? No. So to give a visual representation, right? We draw the field lines. So what are magnetic field lines? These are visual representations of magnetic field. Of magnet. Okay. So it just gives us a visual representation. Right. उससे फायदा क्या होता है देखो. Now you tell me through common sense where should be where the strength of magnetic field is stronger?
Near the poles.
Near the poles, right? So what do you see? The field line property near the poles. They are crowded. They are crowded, right? But when they are away, they are not so crowded, right? So wherever the magnetic field lines are crowded, the magnetic field strength is more. Okay. So this is what is the meaning of magnetic field lines. In the region where I think this you might have written because these are now the properties of magnetic field lines. Where field strength is more, GTH is more, the magnetic field lines are crowded. Crowded. It is maximum at poles. Okay, it is maximum at poles and it decreases as we go away from the magnet. It decreases at a point far away from the magnet. So as you go further and further away from the magnet, the magnetic field strength will reduce. So how can you say that the field strength is reduced? How will you verify that? One is if you draw the field lines, it will be spread apart. will not be crowded. That's one. Second, you can see that the magnetic compass deflection also reduces. In a stronger field, the deflection will be more. Like original direction is north-south. If it deflects more, that means field strength is stronger. Right? Okay, like here it will be almost horizontal, 90 degrees. From north it is deflected 90 degrees. But other places it is deflecting less. Clear? So this is how you will tell where the field is strong and where it is weak. So are you getting the idea? And then the remaining properties of magnetic field lines I've already told you. Right? So there are some 6-7 properties of magnetic field line. You can just go through it again and see if you need any help. Go through the properties of magnetic field line. What are the properties? Quickly. Goes from north pole to south pole outside the magnet. Okay, and south to north inside the magnet. This is one. No need to write, you have already written. Okay. Second, it will not intersect. Will not intersect each other. Because if the magnetic field lines intersect each other, what happens? What is the direction of magnetic field?
Then
First tell me what is the direction of magnetic field? It is along the yes. See, you have to understand that's one part. You have to also be able to articulate or write in the sheet. Just understanding will not help. So, what is the direction of magnetic field? Towards the
poles of the magnet.
So when this is the magnet, so I'm saying the field line is like this. Okay, I'm asking you, what is the direction of field at this point T? Tell me. Tangent, right? So at this point, it will be along the tangent. Now, tangent is a line at this point. Now, it can have direction here also, here also. Which side direction will I take? This point is outside the magnet or inside the magnet?
Correct.
So, outside, how is the direction? North to south. So, its direction will be like this. Okay, so you have to understand. So now let's say if I take a point here. So I take P, Q, and let's say I take a point R over here. Now tell me the direction. What will be the direction of magnetic field at point Q?
Q to south.
North.
North.
Draw the tangent north to south, as it is. So it's not towards south, it's not towards the pole. Where it is towards the pole, either here, only here, or here, towards the pole. Okay? If it is here, it is away from the pole, isn't it? So where you are finding the field direction, that point, that reference, that is important. Understood? What is the field direction at point R?
From south to
From
north.
south.
So here you can, so tangent will be along the line itself. Is it clear? Okay. So in general, you can, so if it is the direction, in general, you can write it like this. The direction of the loop is like this. Is it clear? Because it's very important that you understand this. Now suppose this is north of Earth and this is south of Earth. Right? So the field lines come from south. I mean, it go from south to north. Earth's field line. It is like this. It's like this. So Earth's field line go like this. Okay. If this magnet was not there, then how will be Earth's field line from south to north? We go straight. So in any small area, let's say if I take only this rectangle, then how is Earth's magnetic field? What is the direction now? What is east, west, north, south? Let's say this is north, this is south, this is east, this is west. So Earth field will be traveling like this, vertical, parallel lines. Okay. So in a small space, Earth field line will be parallel lines, traveling from south to north, right? But since there was a magnet, right? Now you see both these magnetic field lines are in the same direction, right? So it will repel. That is why it is not letting. So what will happen? This is south, not pole. This is geographic south. This is geographic south. So over here, there is Earth's north pole. And that is why these field lines are repelled. So Earth field will go like this. Understand? So it is repelling. Okay. Otherwise, it would have gone straight. If I keep a magnet, then this field line will spread out. Okay. This is Earth's geographic north. We will come to this diagram again. So then you will understand the book diagram. So this we will use to understand neutral points. Can you see the field line? So the loops are of the magnet, right? The straight line passing are Earth's magnetic field. There are two types of lines here. Okay. One is a straight dotted line, that is Earth's magnetic field line. And the magnet's field line is making a loop. Is it clear? This is how it is happening. Okay. Okay. So next topic will be magnetic field of Earth. Right. Magnetic field of Earth, that I'll start after the break. Right. There are 5 minutes. What you do is revise all the properties of magnetic field line, all the 7 properties of magnetic field line. See if you have any question. Right. Can I erase this part? Have you written it? All of you, have you written it? This will be after the break. So go through properties of magnetic field lines. So shall I cover from this point by point? Do you have the volume? All of you? You know, somebody read it. Take turns in reading. So they are closed continuous curves. Starting from north and entering at south and then south to north. So these are closed loops. It's not like starting from one and then going endlessly somewhere. No, these are closed loops. Okay.
Sir, what does it mean that they behave like stretched elastic rubber strings?
So if you have a rubber string which is not stretched, so it is uniformly, it has a uniform cross section. Now when you stretch it, what happens? In the middle it will become thinner. So like that. So the magnetic field lines are like over here, it will be like thinner. Okay? Over here it will be thin. But out here it becomes thick. It's like a stretched elastic string. Okay? So the question was, I had asked, they never intersect each other. They never intersect each other. Why?
Sir, if they intersect each other, the compass will point in both the directions.
Compass can only point in one direction, but in both directions it cannot. So that's why it is not allowed. When the lines are intersecting, it will have two tangents. That's not allowed. Since it is a vector field, it should have a well-defined direction. So it cannot have two directions at a point. But if we allow the lines to intersect, then the direction could be here also, here also. That's why it is not allowed to intersect. Okay? It will have unique direction. What else? The tangent at any point of the field line gives the direction of magnetic field. They are directed from the north pole towards south pole of the magnet, outside the magnet. Right? They never intersect one another. If two field lines intersect, there would be two directions of the magnetic field at that point, which is not possible. Okay. So I suggest you use UT volume for this chapter because this is very lengthy otherwise. Here it is given in short. All the questions you should be able to answer with the help of this. So now most of the UT volume content you can now refer. Okay. Because once the theory is complete, so this will help you prepare for the examination in a shorter time. I'm not saying don't read the textbook. For better concept clarity, read the textbook. But for revision, use this. Okay? Especially for the topics which are like descriptive. Okay? Then the next point is they are crowded near the poles of the magnet, where the magnetic field is strong, and are far separated near the middle of the magnet. Middle in the sense, like here, middle, away. Okay, so they are far separated outside, not inside. Inside they are all evenly spread. Okay, what is happening inside? Are you waiting for me to go? Okay. Okay, so uniform magnetic field, I'll explain after I come back. सब घड़ी देख रहे हैं बार-बार. When is it getting over? All right, I'll see you after the break.
Then that's my favorite answer. This. एक बार आ जाए वो पेपर याद इस बार मेरे को पिछले बार से डबल चाहिए पिछले बार नहीं होगा फिर चाहिए क्या पूछे थे कितना हाँ क्या बोला हाँ सबने क्या वो बोला मैंने चलना और आप इसको कहते कंप्यूटर में इंडिया और मेरा बात है मेरे तो अभी 10 खराब होता है अरे मेरे अब मैंने तो ठीक है डर मैंने लूंगी क्या है तुझे को कम कर रहे हो कौन आपका कर चुका हूँ अरे ये तो बोल रहा है उसको क्या बोला जब एक बनी ये फायर बोल बहुत खत्म हो गया कोई चर्च में ये बात करनी
Sure. So all okay outside? कोई room तो नहीं है आपको? Somebody not searching for you, no?
No, sir.
Okay, so any clarification required in properties of magnetic field line? Anybody? Are you in the class? Huh? Or in the wonderland? Physically, और आपका क्या हाल है? I hope everybody is in the class with me. Yeah? So I would rather check it whenever I feel appropriate. Okay, so be alert. So Earth's magnetic field. देखो, this is going to be interesting. So far we have been telling that whenever you suspend a magnet, it points in Earth's north-south direction. Okay, so we'll figure out the reason why. Okay, so देखो, first of all, Earth itself acts as a giant magnet. With its north pole from geographic south along its मतलब अर्थ का geographic south and vice versa. And vice versa. Okay. So if this is Earth, right? So it has its axis of rotation. So this is geographic north and this is geographic south. And the line that passes through geographic north to geographic south is called axis of which is left or right?
The first one.
So axis of rotation. ठीक है ना? This is axis of rotation. So the Earth is going from east to west, right? So this is axis of rotation. But what did we say? Earth itself acts as a giant magnet with its north pole along its geographic south and south pole along geographic north. But वो इस तरफ नहीं होता, थोड़ा सा उसमें tilt रहता है, like this. So Earth itself is like a giant magnet, like this. Okay. इसका मतलब ये क्या है, इसका मैग्नेटिक साउथ है और ये क्या है, मैग्नेटिक नॉर्थ. NM and SM. तो अब इसका मैग्नेटिक फील्ड कैसा होगा अर्थ का? अच्छा, उसमें एक चीज और. So this is your axis of rotation, right? Geographic axis of rotation. तो जो axis of rotation है, उसके जो perpendicular line होती है, what is that line? This is the equator plane. So this is geographic equator. What is it? Geographic equator plane. So it is a circle, right? पूरा अगर एक सर्कल बनेगा उसका अर्थ के सरफेस पे, right? Now, so what should be this line then? What is this line? This is geographic axis of rotation. Geographic. Then what is this red line? Red line is joining both the poles. So what is it? It's magnetic axis. Line which joins both the poles is called magnetic axis. Okay. So this is Earth's magnetic axis. So then the line perpendicular to Earth's magnetic axis will be its magnetic equator. So it is not the line, it's basically a circle on Earth's surface, right? It will make a circle like this, no? On the Earth's surface. Isn't it? Okay. Likewise, this equator also will be a circle on the Earth's surface. You know, na? So this you must have studied in your geography class, right? Why are we saying plane? Because the circumference is a circle, but if you cut Earth in two pieces, so this equator plane will divide the Earth in northern hemisphere and southern hemisphere. Okay, that's why that is a plane. Is it clear? Okay. So what is this? This is magnetic equator. This is nomenclature. Magnetic equator. Okay. Now what is the nature of field lines of Earth? So field lines always come from north and enter into south, right? So how should be the line? If we had a way to draw the field line, it will emerge from the south and it will enter into north like this. Okay. So likewise, in this side also there will be a line which will go like this. Is it clear? This is how it is. So it comes out from the south, geographic south, and enters into geographic north. Now see, this is geographic north here, and the magnetic south is little away. There is an angle between them. So if you just follow the magnetic compass, you will not reach North Pole. You will reach some thousands of kilometers away from it. You got it? So it's not together. And even this keeps changing with time, like over 100 or thousands of years, this position keeps shifting. Okay, so it is not like it is going to change when we start our journey. No, not so soon, right? It changes over long time interval. So is this fundamental clear? How Earth is behaving as a magnet? It is behaving as a magnet because of this. Now imagine this is just a section of Earth. You can see that Earth is circled with this kind of field line from all sides. Everywhere there is. Okay, understood? Can you visualize it? So if let's say there is a small sphere, the field line will be like this. Excuse me. Plane. Okay. So the field lines will come from all sides. Full. Okay. So this is just a cut of it, just a section. Is it clear? So now imagine. So if there are so many field lines, so if you take a small geography, let's say this plane. So how the field line will be? They will be traveling parallel to each other. Isn't it? So there will be field line parallel to each other in a small area. Let's say I take only this much area. Right? There will be so many field lines traveling in this way. Correct? So if I keep a magnetic compass over here, so in what direction it will point? Like this. So this is pointing towards south. Over here, the field direction is like this. So you can see that magnetic compass is parallel. Okay? It is parallel to the Earth's surface. So this is the ground, right? Magnetic compass will be like this, pointing towards north. So it is parallel to the Earth's surface, right? Will it be same at the poles? What is the nature of field lines at pole? So field line will become vertical. Okay, pole pe kya ho raha hai? Field is entering now, and the compass will. So here it is parallel to the. This is Earth's surface, right? It is parallel to the Earth's surface. But when it goes here, it will become perpendicular to the Earth's surface. So pole pe kaisa ho jayega? Got it? Are you able to visualize? Let's see. This is an Earth, right? And the field lines are coming like this. So over here, it is in the direction of field line. So it is parallel. This is the surface. But at the pole, it is entering. So it becomes straight, perpendicular. Is it clear? Okay. So here also. Now here what will be? This is north. This should be south. And this is north always. So north will always be on this side. This is. But here now the magnetic compass is parallel to the Earth's surface. Out here it is not parallel. It will be vertical. This here should be clear. And in between it will make some angle with the horizon. What should be the situation here or here? So see, here it will not be parallel. Now it will make some angle. So this is the angle now. Can you see? Here there is no angle. These are parallel. But now it is tilting. So look at the diagram in the book, textbook. The magnetic compass directions are changing. The shaded one is north. Okay. So this is north. So in the upper region, the north will go down, right? Here it is parallel. Okay. And the reverse will happen in the southern direction. Is it clear? So because of this, the magnetic equator is also defined as the line, right, which joins the point where the magnetic compass becomes parallel at the two ends of the arc. two ends where the magnetic compass becomes parallel. So this line will join those 2 points, magnetic equator. So when you study, read the book, you'll come across all these concepts which I'm telling you. Right? Is there anything you need to understand? Just take few minutes to go through the description written in the book regarding Earth's magnetic field. Just leave neutral points. Everything else you read. Right? Here in the blue box, what is written in the blue box? 2 places where magnetic needle becomes vertical are called magnetic poles. So where it becomes vertical, I told you over here. So here and here, it becomes vertical. Right? Here also it will be vertical. So north will be on this side. Here, north will be downwards. Okay, shaded portion. So it has a meaning, right? So at poles, the magnetic compass becomes vertical, and the line joining the places where magnetic needle becomes horizontal is called magnetic equator. So this line. So let's say this is the point on the Earth where the magnetic needle becomes horizontal. So when you join these 2 points, you get a magnetic equator. So this should be clear. Okay. All right. Now, I also told you about the magnetic field lines of Earth. It will emerge from the geographic south and enter at geographic north. Why? Because the poles are north pole at the south, geographic south, and south pole at the north. Is it clear? So it is slightly opposite. So once you understand it, then it will be easy. Okay? So take 5 minutes to go through it and go through the points given in the volume. It's less. Textbook, it is quite a lot. So whatever is given in the volume, that is more than sufficient. Okay? Every table has a volume. Good. So clear, no? Is it your or no? I'll erase this diagram now. You can follow it from your textbook. So any questions from yeah. So let's understand what are uniform and non-uniform magnetic field lines. So uniform field lines are equally spaced parallel field lines. Okay, pointing in one direction. Equally spaced parallel field lines pointing in one direction. So this is a uniform field line. Okay. So what about non-uniform field line? So one which does not satisfy this is a non-uniform field line, right? So you can see here, this is a uniform field line and all other. Can you see? So non-uniform will be, these are uniform field lines. Are equally spaced. In one direction. So these are your uniform field. So it could be like any set of parallel lines, right? If these are the set of parallel lines, then these are also uniform field lines. Got it? So when will you have non-uniform field lines? So suppose you have two magnets. North poles are facing each other like this. So how will be their field lines now? So it will be like this, right? Will they meet? No. They will not meet anywhere. Okay, so they are not parallel, right? They are not equally spaced either. So this is when like poles are facing. What when unlike poles are facing? Then what? How will be the field line? Let's say this is south and this is north. Now what will happen? What should happen? Like in case of wherever or to nine. That's it. So क्या होगा? Like this kind of an example you will learn. So let's say this is north and this is south. What will happen? So the lines will come out of north and it will enter south. But it will be curved like this. Right? And inside it will make a complete the loop. Okay, this is how it is. So it will complete the loop, but they are not uniform. Okay, can you see it uniform? No. Right? So wherever the field lines are not parallel, then it is not uniform. As simple as that. Clear? So तुमको diagram दिया question में पूछा identify whether it is uniform field or non-uniform field. Immediately you should be able to answer. Or there may be a question, draw uniform field line. Then what you will do? Just draw a set of parallel line pointing in one direction. Okay. Clear? Acha. Next concept is neutral points. First, we'll write it. Then. Neutral points. What is neutral points? So it will fall under combined effect of Earth's magnetism and bar magnets. Can I erase left side?
Yes.
Yes.
So combined effect of Earth's magnetic field and bar magnet. Earths and bar magnets magnetic field. Okay. So let us say this is the direction, like north. This is east west. This is the direction. Like this board is the plane of your, page, right? So for you, north is on the away from you, right? North is away from you. So what is the direction of Earth's magnetic field? Earth's magnetic field is always in the upward direction, everywhere, right? Because it will go from south to north, right? Now we will see two cases. Case one, north pole of bar magnet along geographic north. Meaning, now I have kept a bar magnet like that. How is the bar magnet? Like this, right? So how will be its magnetic field? Its magnetic field will be symmetrical. It should not be the mirror image of left and right. Okay. So south to north like this. Right. Here also. Right. Now what about Earth's magnetic field? So you see the Earth's magnetic field are in this direction. So how should it go? Now this is going up and this is coming below. So it should be attracted, right? So Earth's magnetic field should be like this. It should be attracted, right? Because the direction is upward. Okay, it is attracted. But what should happen, right? At some point away, this field will become equal to Earth's magnetic field. But their directions are opposite. So what will it do? they will cancel each other. Right? That is neutral point. So somewhere here, right? There will be no, so when you keep the compass over here, it will point in any direction because the Earth's magnetic field has been cancelled by magnet's magnetic field. Right? यहाँ पे Earth is going upward and magnet is coming downward. And their magnitudes are equal, just the direction is opposite. So they will cancel each other. Got it? So when the north pole of the magnet is, you see this diagram. So how is the magnetic field now? So everything goes, so just draw the field the way it is drawn in the book. Only the loop is in the side, right? Everything of the earth also will go here. But when you go away, right, there it will cancel. Right? So draw this diagram. Okay. So this kind of magnetic field you will get only when the magnet is alone. But under the influence of earth, what will happen? Here the earth magnetic field also will enter into it. So the combined effect will be something like this, as shown in the book. Like this. Okay. And these curves will just end in the side. Side में बनाओ ऐसे. Can you see the book diagram? You may not be asked to draw because this will be difficult for you to draw, but at least you should understand how it has been drawn, right? See figure 10.9 in your textbook. Instead of volume, you see the diagram here. This is more easy. So few diagrams, right? So when the north pole of magnet is along the north of the earth, the earth magnetic fields are also entering the south of the magnet, right? And it is going away. Why it is not able to complete the loop? Because when it is coming down, right? This is north only. So it is being repelled away by the earth's magnetic field. Because what is the direction of earth magnetic field? Upward. That's why it is like becoming like this. Is it clear? When there is no field, then it will come from here and enter the south like that. This is a combined field. Is it understood by everyone? And why these are neutral points? Because the earth magnetic field is cancelled by, see, near field is not cancelled because the near field is stronger than the earth. So near field will be shown. But as you go away, magnet's field become weaker. And therefore, it will be equal to the earth's magnetic field. And then they will cancel. So this kind of point where the earth magnetic field is cancelled by magnet's magnetic field, it is called neutral point. So at neutral point, do we have a magnetic field? No, because it is cancelled. Okay, understood what is neutral point? So let me just give you the concept of neutral point. This is N. So the kind of question asked is, where are the neutral points when the north pole of the magnet is right along the geographic north of Earth? So neutral point is along the line which passes through which perpendicularly passes through the midpoint of the magnet and is perpendicular to the magnetic axis. Is it clear? So where is the neutral point? Right now. So first write down what is neutral point. It is a point where Earth's magnetic field is opposite, equal in magnitude, and opposite in direction to the magnet's magnetic field. Right? Hence, the net magnetic field at neutral point is 0. This is what you should understand. Equal in magnitude, but opposite in direction, like here. Right? So note. When north pole of the magnet is along the geographic north of Earth, the neutral points lie on the perpendicular bisector of the magnetic axis of the bar magnet. Right. The neutral points lie on either side equidistant from the center of it. Hope this is clear. When north pole of the magnet is along the geographic north, so first you write, then I'll explain once again. Is it clear to everybody? So everybody know understood what is neutral point? That point where the net magnetic field due to Earth and the magnet is 0. Okay. Now there are two situations. When the north pole of the magnet is along the geographic north of the Earth. Okay. When the north is along the geographic north of Earth, then where is the neutral point? It lies on either side of the magnet on the perpendicular bisector of the magnetic axis. The magnetic axis is this line joining both north and south pole. What is the perpendicular bisector? This. So it is on the both sides of this perpendicular bisector, and it is equidistant. So this is the center. So let's say this is A, O, and B. So AO is equal to OB. This is what it means on both sides. AO is equal to OB. Clear? Now I'll give you one task. Case 2. Now the south pole of the bar magnet is along geographic north. Now you tell me where it should be. Okay. Now draw the neutral point where it should be. So we have the south pole along geographic north. Now remember, Earth magnetic field is in upward direction only. Everywhere. So what about this? Here the field should come like this, isn't it? So it is coming out. Then obviously, where is the opposite field line? In this direction. Right? So how is Earth's field line? So it will repel it. So it should go somewhere over here like this. Isn't it? Because here the field directions are in the same line, so it will repel it. But this line somewhere will cancel it at some point over here, either over here and likewise over here. Because here the field line is coming down. Okay, somewhere here it will cancel it. This Earth field is going up. So in this case, the neutral points will lie on magnetic axis on the two sides, equidistant from the center of the magnet. Is it clear? You can see the diagram in the book. So that's diagram 10.10. Okay. Can you see the cross? Here and here. Can you see the cross? X, X. So the cross is the neutral point. Clear? So depending upon how which pole is along which side of the Earth geographic direction. So when south pole of the bar magnet is along geographic north and the neutral point lie on the magnetic axis itself, equidistant from the center of the magnet on either side. Clear? Right now. Case 2. When south pole of bar magnet is along, so you draw this diagram, don't draw the diagram. So that's a conceptual diagram. This diagram. 10 point, write down this diagram, 10.10, textbook diagram. Earlier was diagram 10.9, textbook. Okay, bola diagram. ये यहाँ से मत करो because it is slightly difficult to draw. So when write down the title of this diagram, south pole of bar magnet along geographic north of bar magnet. In this case, write down, in this case, the neutral points, in this case, the neutral points will lie on the magnetic axis of the bar magnet on either side from the center of the magnet. Okay. Then you can draw this diagram and mark this. These two different ones. Okay. Now one more question. So this is the second node, right? That thing will appear in the second node. Third, at neutral points, the direction of magnetic compass is, where should be the direction of magnetic compass? At neutral points. Is there a magnetic field at neutral point?
No.
So what should be the direction? Any random direction. Okay, it's arbitrary. Okay, is any random direction. As there is no magnetic field at neutral. Okay. Yeah. So do you have any questions still here? Clear, I hope clearly. You can read the blue box. So this is a deep concept, right? So try to make it as simple as possible. Shall we go a little more deeper in this? So now see, this Earth's magnetic field has actually two components, horizontal and vertical. Does it make sense? No.
Today.
Earth's magnetic field has two components, horizontal and vertical. Right. So what happens is, like I told you, so if this is Earth, imagine this as a sphere, right? Now, as you go from the equator area, at equator the compass is parallel to the surface. Let's say this is the equator area, so the compass is parallel, right? But the moment you go in the upper hemisphere, above equator, then the angle is tilted like this. It is no more it is no more perfectly horizontal, right? So when it is tilted, then we resolve two components. Now it has a horizontal component like this and a vertical component like this. There are two components there, right? Initially there was only horizontal component where in the equator region. But the moment you shift up in the upper hemisphere, I told you the compass tilts like this, and at the pole it becomes vertical. So it has no horizontal component at the pole. It has only vertical component. At equator, it has only horizontal, but in between it has both